Rachel is a TQ regional instructor entering her 17th year of teaching. She teaches AP Statistics, Quantitative Reasoning, and Algebra 2 at Columbus Academy in Ohio. You can find her tweeting about mathematical modeling and inquiry-based physics on Twitter at Rachel H. Gorsuch. So, Rachel, thanks for the shout out and reminding me to unmute. And we're excited to have you here. Steve is a T-Cube national instructor entering his 32nd year in education. The past 3 years, he served as an instructional technology consultant for the Hamilton County ESC. He has moved into a new role as an instructional technology coach, a math coach, and a math and computer science teacher for Marymount Schools in Cincinnati, Ohio. He's active on Twitter at MathTechCoach, where you can connect with him there. So, Steve, we're excited to have you with us tonight.
Thanks, everyone.
And so my introduction, I just have to redo it because I thought it was so good. I just wanted to thank everyone for joining us tonight for this Tuesday night webinar hosted by Texas Instruments. And I'm guessing that you may have heard of the Monty Hall problem, but what about its variations? And what about using the problem to teach probability concepts? And again, with us tonight, we have Steve Phelps and Rachel Gorsuch, and they are the perfect teachers to help unravel all the mystery. Rachel, will you talk through hopefully some of our expected outcomes for tonight?
I'd love to. So we're hoping and expecting that what you'll get out of this tonight is the ability to use intuition and to feel confident and use simulations and calculations to work on the Monty Hall problem with us. We want you to be able to walk away from this to be able to engage your students in learning about randomness using this strategy. And we also hope that you feel a little more confident after tonight using probability puzzles to engage students in the learning of probability.
Rachel, thanks so much. We're expecting a large crowd tonight, so your audio is muted, hopefully not ours. Feel free to say questions to Rachel or Steve using that Q&A window on the right side of your screen. We'll also be very active in using that chat window tonight, and we'll be talking about that in a little bit. As a reminder, the session is being recorded, and we'll provide a link to the event certificate of attendance at the conclusion of the webinar. Steve, I think I can give you control, and it's time to get the party started.
Oh, my. Hello, everyone. Man, welcome. This is going to be a lot of fun. I'm excited. So let's make a deal, exploring the Monty Hall problem and its variations. And this is like the variations. I know the Monty Hall problem. I didn't think about the variations that would be involved. But let's see. So here's our agenda. And there's some ground rules too. So we need to do some ground rules, and we'll try to practice this before we start. But this is not going to be so much about coding and writing code as it is going to be about this instructional arc for teaching probability. We're going to engage you all in this instructional arc through the Monty Hall problem. A part of this instructional arc is the idea of a simulation, and Python on the Nspire is the perfect tool to conduct a simulation. There are some variations of the Monty Hall problem. One of those variations is the forgetful Monty Hall problem. And then there's another one that we'll add if we have time, which is the lazy Monty Hall problem. And so now we know that some of you are familiar with this problem. And so we would, I humbly ask that you guys kind of hold back and let others who don't know of the problem to kind of experience that wonder and aha and that puzzlement that comes along with the Monty Hall problem. So to help us do that, we will, I love instituting the magic word policy. So these are our ground words, the magic word. So what we'd like you to do, we're going to ask a bunch of questions tonight, and we'd love for you guys to put this in the chat. And I know is, well, I got something pop up from my web apps. So I know that Rachel's going to be keeping an eye on the chat. But so we'd like to do is like type in your answer, but don't press enter. And what we'll do is we'll give you guys about a minute to kind of get your responses together. That way, folks who think a little bit slowly can kind of still feel good. And then the magic word will be Monty. So when we say the magic word Monty, that's when you can press enter on your chat. So let's practice that once. So do me a favor, find the chat. There's a little button in the lower right-hand corner of your screen. And if you click on the chat, type in tonight's magic word, but don't press enter. And also a yes or no, like yes if you know of this problem, no if you don't know of this problem. And I'll give you guys about 30 seconds in my head. I'll count kind of quickly, and then I'll say the magic word. So you're going to put in the magic word, but don't press enter, and yes or no for yes if you know the problem, and no if you don't. And since goodness gracious, I can't see. Oh, there's a chat button. I see a chat button. All right, kids. Let's see how this goes. I'm excited how this is going to work. I'm excited. And the magic word is Monty.
Oh, and the chat just flooded. That's what we love to see. That time for everybody just to think a little bit and have time to respond and think about their responses before like that knee jerk. I know we're all teachers. Man, we think on our feet really quickly, but it's also 8 o'clock at night. We're gonna give ourselves some time just to like check what we're writing. And I love it. And Steve, there's just like a whole mix. We've got yeses, we've got nos, we've got kindas. It's gonna be fun tonight.
I think it's going to be fun. We're going to find out. Oh, I went the wrong direction. So here's this.
I'm going to interrupt you. Sorry, Steve. One more thing for the agenda because I was entrusted with this. So Mike Houston said at the very end, we want to ask people to hang out for just like a couple extra minutes. Turns out that TI is going to give away a calculator at the end of this webinar. And so we encourage you to hang out at the very end and maybe you'll get a nice calculator and you can do your own Python on it. Sorry, Steve. Thank you.
I had a sticky note sitting right there, right on my table, and right below the other one about this is not going to be about coding. Anyway, so here's this idea of teaching probability. This is not an original thing, but it's kind of a hodgepodge of ideas. 3 of the 4 things came from Alan Rossman. Intuition, simulation, and calculation were from Alan Rossman. The confidence wager idea came from the American Statistical Association back when COVID first started. They ran a wonderful online activity called March Randomness, and then I've also played the dice game Burrell. So the confidence wager is the intuition is like, what does your gut tell you about the probability scenario? And the confidence wager is like, how much would you be willing to bet on your gut, if that makes sense? And then we have a couple levels of simulation, and then calculations. We'll show you one calculation if it would even be considered a calculation. But I honestly feel that sometimes the calculation is gotten to too quickly, and they never develop strategies and like a feel for randomness and how randomness works. So I love this instructional arc. Rachel, any thoughts on that?
No, I totally agree with you. I didn't start off teaching statistics with using simulation. I started off by teaching formulas and my kids never quite grasped it as well as I wanted to. And so I started exploring more. I was like, what can I do to make this better for students so that they 6 months from now, it's still like with them. And you're exactly right. It's the simulation, just developing that gut intuition for what they're seeing. So this will be a great example of that.
So by intuition, it's important, I think, to let the kids make a guess. So, and not, I have put a number on it from 0 to 1 as a way to introduce this idea of how we measure randomness, if you will. But, is this likely to happen or unlikely? Is it certain to happen or will it never happen? So give kids a chance just to go by their gut. Don't give them a lot of a lot of time to do calculations. Just what does your gut tell you right away? And then the confidence wager I got with again, like I said, from the Statistical Association and the March Randomness, they had a stat coin feature where you could say yes or no to a probability scenario if it would happen or not, and then you had to bet like so many stat coins. But just as enough as like, how confident are you? On a scale of from 1 to 4, how confident might you be? And I like using the even numbers, so there's not going to they can't sit on the fence. And then the simulation gives kids an opportunity to test their intuition and to revise their intuition. So we kind of have simulations set up in a couple of levels. One simulation will just test one trial at a time, so you can kind of get a feel for what's happening. This could be dice. It could be doors with cars and goats behind it. We will use Python tonight, but there's no reason why you couldn't use TI Basic or just lists and spreadsheets on the Inspire. I think either of those would work. But our tool tonight will be Python. And then the calculation is kind of the last thing that we do. Not really sure that calculations will always reveal insight into randomness or random processes. But certainly if you're going to do calculations, it does not need to be by hand. So it's certainly possible on the Inspire that you could compute or actually list every single outcome. For example, if I have 3 6-sided die, I could actually list every possible outcome that there is by writing a short Python script. You could also do the same thing in a list and spreadsheet. So not all the calculations need to be done by hand, and not all the calculations necessarily lead to insight into randomness or random processes. Anything to add, Rachel?
Nope, I like what you're saying.
The Monty Hall problem. So if you're not familiar, so let's test it again. In the chat, do not press enter. Who has ever seen the original Monty Hall show, Let's Make a Deal? Don't press enter, type in, yes, I've seen it. No, I haven't, in the chat, and wait for the magic word. Wait for the magic word. Oh, wait for the magic word. The magic word's Monty. Go. Yeah.
A lot of yeses.
So 1963, 1 year before a good year. So so again, you guys know there's a current version on now, but members of the studio audience are making deals with Monty, and the audience members typically are offered something of value, and then they're given a choice. Like, would you like to switch that? I love this idea. Would you like to switch this for something else that may or may not be of greater value? Monty Hall was the inventor, starter of this. So that's something I didn't know as I was doing the research on this, but that's the Monty Hall problem. And so the Monty Hall problem is loosely based on this puzzle. I'm sorry, loosely based on the game show this puzzle is. So there are 3 doors, and you get to choose one of the doors. Behind 2 of the doors are goats, or some sort of like a prize you don't want unless you like goats. And then the other one is a car. A car is behind the other door. And so you pick a door, and without knowing what's behind the door. And so say I choose number 1, then Monty says, well, here's another door, and he'll open one that has a goat behind it. And they'll ask you, do you want to switch? Would you like to switch to the other unopened door? And so that is the basis of the Monty Hall problem. And so the idea behind it is it to your advantage to switch your choice? So without pressing enter, what does your gut tell you? Type in yes or no. Don't press enter. Type in yes or no in the chat, and I'll give you a little bit of time to do that, and then we'll say the magic word. And please do not put any if you know the problem, please don't put any probability wagers in there or things like that yet, but a yes or no, and the magic word is Monty.
Monty. Ooh, I love all the gut, and I love that people even said too, like, my gut instinct says something, but they're like, I don't know, it feels like a trick question. That's kind of I think our students do that all the time too. They're like, I don't know, you wouldn't be asking me if it wasn't a trick question. Steve, I have to confess, I've never seen the original Monty Hall. Like, I've never seen that, but I fell in love with this problem watching Mythbusters. Actually, it was one of their episodes, and I'll put it in the chat. But as I was watching it, the way Mythbusters approached it is they actually ran the experiment. They did this experiment again and again and again and again and again. And with so many trials, they started to get a feel for it. So that's part of what I've shown my kids. It's streaming on Discovery Plus, so I'll put the link in the chat. But even if you haven't seen the original, you can totally appreciate it through Mythbusters too.
Nicely done. So here's our next step. So you've responded to what your gut tells you. Now in the chat, don't press enter, but how confident are you in your answer? If you're very confident, put in a 4. If you're not so confident at all, put in a 1. If you're somewhere in between, choose from 2 or 3. So don't press enter yet, but put in your confidence level. And then we'll say the magic word. The magic word is
Monty.
And so this is what I wish I would have done. And I always say this, like, I wonder if people who said yes are more likely to be very confident than people who said no. I mean, I wonder if there's an association between the yes and no answers and the confidence level that they assign to their answers. That's what I don't know. I'd like to figure that out. So let's go. I'm going to switch over from this, and we're going to probably run most of the rest of the night from the from my Inspire. So let me shrink this down, and ta-da! And so this is the classic Monty Hall. And so what we'll do is, yeah, that is certainly true, Michael. That is certainly true. So on the classic Monty Hall, there, let's just run. This is the code to it will allow us to run the simulation one at a time. And so it will give us the choice: do we like to switch or not switch? And let's see how the results kind of come out. And so I will build it and then run it. And so we are prompted, do you want to switch? And I will give you permission to put in a Y or an N in the chat without waiting for the magic word. So go. The first thing I see in the chat, I see a yes. So I'm going to go yes.
Yep.
So when I go yes and press enter, so we ended up winning that game. And so let's run it again. So should we go yes again or should we go no this time?
Oh, I saw a no first this time.
I go no.
Yeah. I feel like I'm on The Price is Right, like listening to the audience screaming behind me. Oh my gosh, I'm getting pumped up right now.
So it seems like we've done 2 samples. The yes came up win and the no came up lose. So maybe we should switch after just those 2 results. So let's run this a couple of times in a row. What should we always do? Oh, I like you guys got confidence wagers. I didn't even talk about confidence wagers. Nicely done, kids. Nicely done. So let's run yes like 5 times and keep track of if we're winning or losing. So on the run, and I got to go yes. And oh,
that's a lot. I'm going to keep track. 1 loss. A 2nd loss. A 3rd loss.
That's probability. That's
probability.
Just never know.
We win.
All right, and let's do one more. One more. Ready? So we ended up 2 wins and 3 losses.
That's right. And Steve, I love it because you are a true statistics teacher. You're like, I said 5 trials, I'm doing 5 trials. Where the kids are probably like, no, we should do 10, we should do 15. That's not what I was thinking.
Let's do 5 in a row with no's. And see what happens. So we did 5 in a row with yeses and they came out. You lost 3 times. Okay. Yeah. So let's run it again. And we'll go no's.
1 loss.
2 losses.
2nd loss.
Oh. Let me try this again. Oh my gosh. I think I clicked off the screen by accident and it wasn't working. There you go.
We won.
So there's a chance. There's a chance.
We lost.
So if we get a yes on this one, it's going to be the same record.
We tied, yeah. We tied, yeses and nos.
So maybe it's a different show. Anyway, and I love this guy. So does based on those results, would you like to switch your answer? Don't press enter yet, but would you like to switch your answer, like either from yes, we should switch, to no, we shouldn't switch, or maybe it doesn't matter? Would you like to change your answer, and what would your new answer be? So put that in the chat and wait for the magic word. The magic word is Monty.
There are a lot of people saying no. I'm sticking with my original answer. I'm going to stay with no. But Michael says I'm switching. It has to do with the law of large numbers. But I'm going to stick with my original gut instinct.
So this is good, man. This is good. So let me go to the next one. This is we've gone from these singleton simulations, and now I want to generate a lot more. And so this is if you're looking at this and you pick up on the Python, there are two for loops that are going on. The inside for loop is running the game, and I've got two variables. The number of games we'll run first is 100. So we're going to run 100 games and keep track of how many times we win those games, and we'll set our switch to either true or false. So it'll always be the same. We're not going to make a decision. We're going to make that decision up front and see what happens. And then we can do this those 100 games 100 more times and collect the data. And so right now my switch is set to false, and we can keep it at false. That's going to be fine. And then the number of games we'll run, individual games, is 100. Number of trials is 100. And we've got this connected to the spreadsheet. Listen, actually, the data and statistics page on the handheld, and we will send those results there. If I could only get my, there it goes. I think I did. I think I grabbed that. Perfect.
Steve, while you're playing with that, can I ask a follow-up question for the chat?
Yes.
So I saw someone mention the law of large numbers, and what I'd like to ask in the chat is, we did this original trial this original simulation with 5 rounds, and now we're going for 100. So what do you think? Are the results going to be more, I don't want to get too like statsy with this. I'm going to say this. Are the results going to be more truthful, more like their original scenario, or are they going to be less like the original scenario now that we're choosing to run 100 trials instead of the 5 trials? So put your answer in the chat, but don't press anything yet. Do you think that with 100 trials, we're going to be closer to the actual answer of what happens on the game show or not? I swear, wait time is always so much harder on Zoom or any of these WebEx. Go ahead, and the magic word is Monty. Oh, we've even got a claim that we should go for 1,000 eventually. So we've always got the next step out in front of us. Okay, so well, let's see what happens.
So we'll run this. Nope, maybe I will run it if I'm in here. So let's build it and run it. And so what I've done is, you can kind of see in my screen. That is weird. Oh, because my screen is now very, very tight. So there you go. It's a little bit better. That's kind of a weird looking screen though, isn't it? So this is 100 trials, and each dot. So for example, that dot right there means out of 100 games, Monty Hall games, we did not switch, and we won 25 times. And that occurred 3 times. And then on the other side of the screen, but this is like a Zoom, just like a Zoom meeting, the Zoom windows are always in the way, so I can't see anything. So I think on the far side, I'm just going to move this over to the left a little bit. It looks like that we also won 46 times. But it seems like all of these dots are less than 50. So I'm wondering if we, by not switching, we're kind of probably going to end up losing, because if it held on to 50%, then maybe it would be okay. So someone said they wanted 1,000.
Yeah, someone said in the chat.
So let's do let's play the game 1,000 times, but we'll do 100. We'll do 100 trials of that first. So I'll build it. I will run it. And then we'll have to go down here, because since we've used, I will zoom stat on that puppy, or zoom data. And so this is 100 trials of 1,000 Monty Hall games. So this dot right there, where we always, Monty Hall games where we never switch, we always stick with our original result. So that dot right there represents a game where we won 355 times out of 1,000 times by not switching. And now I think the results are even more pronounced. We're not really close to the 50% mark, are we?
It doesn't look like it. No.
So we should probably go and do this 1,000 times just for kicks.
Michael's asking, since this does look a little bit skewed, do we know what the median is on that set we did?
We can, so let me go back and find, would you be satisfied with a box plot?
Michael, I'm keeping an eye on the chat. You let me know. Michael says box plot's cool.
So
well, he didn't say exactly that.
It looks like my median is at 334, which is around where it should be, but no outliers. But I wonder if that will change when we run 1,000 trials of 1,000 games.
So Steve, my students always ask me, they're like, why are you doing 1,000 trials of 100 games? Why not just do 1,000 trials, period?
I like to see how it grows. I like to see how the shape of the distribution changes.
Yeah. And I always tell them, I'm like, the show is on for multiple seasons. It's almost like you're looking at one season and another season and another season. And then you're kind of looking at the big picture of everything. And that's what these distributions help us see is the bigger picture.
So we'll do 1,000 trials of 1,000 games, and we'll build it and we'll run it. And I don't know what's going to happen. Oh, it does freak me out. Let me zoom data. That looks like fingernails on a chalkboard. So
I thought a kelp forest, but now I can't unsee fingernails on a chalkboard.
So this is a really nice. This is a nice. Should I do histogram?
Oh, that'd be nice. Yeah.
So nice little bell shape. And if I go up here, we can kind of rerun this a couple times. Now think about this. There's a lot of stuff that's going on. 1,000 trials of 1,000 games. That goes pretty quick, and that. So that was by not switching. That was by not switching. So we should try one more before we go on. We should at the very least, if we change switch from false to true, where should our piles be close to? So when we switched, our pile seemed to be centered around, like in the chat, 1/3.
Mm-hmm.
So in the chat, put it in, wait for the magic word though. If we always switch, where should our piles be centered now? And the magic word is Monty.
Well, I always love it when some people are doing decimals, some are doing fractions, some are doing percentages. I love that.
So let's see. So I'll build it and run it. And everything disappeared. So I will go zoom data, and it's probably going to be somewhere. There you go. And we probably should make a box plot out of this. We should make a box plot. And so hover over it, and we have outliers. but the median is 665 wins. That's pretty darn close to 2/3. And yes, the classic Monty Hall problem. So it seems like you want to switch. You want to
That's what the
switch.
simulations say.
Yeah.
Yeah.
So if you want, I think Rachel had a picture of this. There is an easy code version of this if you wanted to get this and run it with your kids. So if you want to take a screenshot of this or take your camera and grab a picture of it, this will run this range number here. This will run it 100 times and it will return the number of wins out of 100. So if I build this and run it, I have 63 wins. I have 69 wins. And I think I'm always switching. I don't think you can change it to like to not switch down here at the if statement. And I give you a comment on what you need to change to turn it into like a staying. But it's a nice simple code that you can run. And then if you would like, this code will generate 100 trials of 100 trials. And so I set that code. So if you want to grab your camera or your phone and grab a picture, and this will also run the same thing, and it's going to store that list. It'll store it to a list and spreadsheet or a data and statistics page. So there's your data. It's kind of weird that I don't know why I'm getting that weird. Like I'm getting a lot of gray area. I don't know why it's doing that, but anyway. Okay, so let's look at a variation. Let's look at a variation. The forgetful, there are boatloads of variations. And this I thought was kind of funny, but it's kind of weird. So we need to think about this. And again, your intuition is going to be tested because you probably do not know about this game. So the forgetful Monty Hall, the forgetful MonTI Hall works like this. So Monty forgets what door the car's behind. And so in this case, you can win, lose, or have a game ruined by a forgetful Monty Hall. So folks, should we switch or not switch? Write your answer in the chat. Don't press enter or return. Let folks think about this for a second, but what is your gut telling you? So in the forgetful Monty Hall, should we switch or not switch? Yes or no? And the magic word is Monty.
Ooh, I feel like we're about 50-50 now. Like it's definitely not as much that people are saying automatic switch, automatic switch. Now we're kind of down the middle. We've got some who want to switch, some who don't switch. So some people saying it depends. So, or that it doesn't matter, makes no difference.
I think we have a Monty Hall fight on our hands.
I do too.
So how confident are you? So don't press enter, but put a 4 for most confident, 1 for least confident, or a 2 or 3 in between. We should have done this all at one time. We need to remember this for the last one.
We do.
So put in a 1 through 4 for your confidence level and press enter when I say Monty.
We got decimals this time.
But I'm also
That's
seeing I'm seeing fewer 4s this time also.
I agree with that. More 3s and 2s, I think.
Confident, there's some confidence, but not like that would be like if I had to bet like 1,000 stack coins or 400 stack coins, I'm going to go 400 stack coins. So what I
Oh wait, we're gonna just real quick clarify. We've got a question in the chat.
yeah.
So what exactly do we mean that Monty forgot which door the car was behind? So why does that matter? Does that mean that there's a chance he reveals the car and then we're not able to switch and we're just kind of out of luck?
So what I've done in my simulation and from reading what other folks have done, they call it the game is ruined. So there's like a no winner, no loser. But it seems kind of weird, but do you win a car is what we'd like to see. It is possible that Monty could reveal the car. Yes. And so what I've done in my simulations is if you win, I will assign that a value of 1. If you did not win the car, I would assign that a value of -1. And if the game was ruined, I assigned that a value of 0. So when I put all of those numbers into a list at one time, I can just add the list together, all the elements in the list, and that number will tell me if there were more wins or losses. So that's kind of how I approach this game. But let's play it a couple of times and see what happens, because I really have no idea what's going to happen. So here is my we're always going to switch. We are always going to switch. That is the rule. We are always going to switch. At least in this game, we can come back and change this around. And so what we'll do is we will have a list in our shell about if we won, if we lost, or if the game was ruined, I think is the other thing that is also there. Game ruined. So let's run this. And so the first time we did it, we were switching and the game was ruined. So let's run it again. Game ruined again. Game ruined again. And there you lose a game. So we've had 3 games ruined. There was a win from earlier, so we could certainly count that if you wanted to. So I wonder what's going to happen next. A win. We were due for a win.
That's how probability works.
That's not how memory. So let's see what happens. So there's another win. So it seems to me like I'm going to win twice as many times as I lose. 3 times as many. 3 times as many times. Oh, there's a lose. So what do you guys thinking? I don't know. What do you guys put your thoughts in the chat? Don't press enter. Put your thoughts in the chat. I see some wins and losses. I don't know if it's like maybe slightly more wins. I don't know.
And we're given some wait time because we're asking for like a whole thought here, not just a real quick, oh, it always wins, it always loses. Here's, like, why do you think what you think? We're always asking students to do that too. Like, it's not about the answer, it's about understanding why you think that. So feel free to take just an extra moment to explain why you think what you do.
Oh, this is perfect. The time is perfect. Shall we mention the magic word, you think, or do you need a little more time? What would you like to do, Rachel? You can be in charge of the magic word.
I feel like I'm gonna go, if only because I'm so excited to see what people are saying. I think I'm gonna go with the magic words. So the magic word is Monty.
Monty.
Ooh. I'm having fun reading all these too. So we're getting a lot of 50-50s here. Now it's more equally likely that we're gonna win or lose the game. If the goal is to win and the ruins count as losses, then switching should give you the same chance of winning as staying, I think. And it's possible that people are still typing too, because I asked for that thinking behind it, and I know some of us type really fast, and some of us are just like putting all those thoughts together, but we're thinking closer to 50-50 now.
So we do that little singleton simulation. So that could be like I could just be rolling dice in my classroom. I'm doing a simple single simulation or a trial. And so now we can gather a whole bunch of trials at one time. So as we did before, we will play the game 100 times. and we will keep track of our wins, losses, and games ruined by assigning ones, negative ones, or zeros. And then we'll add all that stuff up and put those sums into another list of data, and we'll do that 100 times. So we'll do 100 trials of 100 games. So build it and run it. And let's scroll down to this, and ooh. What on earth does that mean? So take a gander at that distribution. And if you jot down in the chat, what does that distribution reveal? Don't press enter, but just type your thoughts in. What does this tell you about the likelihood of winning? I'm actually glad it came out with that scale.
Yeah, that scale is interesting.
Well, because I originally had it 1,000 trials of 1,000.
Oh, yeah, that makes sense then.
But this is actually, because if I zoom data, it's going to spread out. It's not as revealing as that other one. So press Monty. Here's the magic word. I appreciate you guys waiting for me to say Monty as we are talking on another tangent. So yeah, so I'm wondering if it is winning and losing a card, but I think really I think it might have been mentioned before. I think having the game ruined, winning a car, winning a goat are all equally likely, probably. So let's do this one more time, and then we'll go to our last little variation of the night, because I can't believe our time is, oh my goodness gracious. Mike said we could go till 9:30.
Time flies when you're having fun. That's
Right.
that's
So
what's happening.
let's do 1,000 trials of 1,000 trials. So I'll build it. I will run it. Let's zoom. We'll zoom data on this. I really do not like all that gray area. It's kind of weird, but that's a nice little pile. And so I failed to discuss what the dot means. So this dot here, that dot of 13 means in that game, there were 1,000 games played. You won 13 more times than you lost. And we have no idea on how many games were ruined, because that counted as a zero. So the sum of my ones and zeros and negative ones were 13. Whereas this one, that was just a bad day. Negative 81. So you lost 81 more times. But that is randomness. And that's kind of the idea behind this instructional arc, is kids hopefully will understand that a negative 80 and a positive 80 could both occur. So, all right, let's go. This is, have you guys seen this one before? Yes or no? And you don't need to wait for a magic word. Have you seen that variation before? It's kind of weird.
I have to confess, Steve, you were the first one to teach me about forgetful Monty Hall problem. So
Monty Hall. So then you guys will love the lazy Monty Hall. So the lazy Monty Hall is kind of the same thing could happen. It is possible that because Monty Hall is lazy, that he could possibly choose the car and ruin the game. So that is certainly possible. And how it does it is Monty he doesn't like to move too much. So he opens the door he's closest to. And so what I did in this idea is I kind of modified the lazy to make it a random Monty, is that he is more likely, there's a 75% chance that he will choose the leftmost door that was not picked. And you'll see it. And if you're a Python user, I'm putting everything in a list. And the leftmost door would be that door at index 0 for the Python users. So that's what I mean by the leftmost door. So ready, get a should you switch? Yes or no, don't press enter, but take a couple seconds. Do you want
And
to
wait. We're also going to put our confidence. So should you switch, yes or no?
Yes.
And your
Yes.
confidence 1 to 4.
And confidence. Yes or no, how confident are you? And the magic word is Monty. Oh, that was much, much better. I got to remember this. I got to remember putting this. Again, I think I see a lot of yeses and nos, or no. I think there's more nos than yeses. I don't know.
I think we're shifting. So that first set of people who responded, who were kind of like hovering over their enter key, they had a lot of yeses. But now the second group that's coming in has more nos. And so I would have to scroll through all of them to see if we're about 50-50. But initially, I think, oh no, yeah, I think we're at about 50-50.
So we're always going to switch. And this is a single. What's it? Yes, there it is. I should probably comment that part out so we don't need to see that, but let me build this and run this. And so so we switched and we won by the lazy Monty Hall. Let's run it again.
Oh, 1 win.
Yep,
Oh,
and
we
again,
got ruined. I don't know if I have enough hands for this.
2 wins. Oh, it's looking like a win. I think we're going to win every time or ruined.
Oh, that's a ruin. Another ruin.
We're due for a lose now, aren't we? Oh, yeah.
I feel like I got to put my foot up to keep track of the third one.
So in the chat, do you want to change? Do you want to change your gut? Don't press enter, but would you like to change after seeing these singleton simulations? And these are done by switching every time. So the magic word is Monty. Yeah, no. So I got a no. No one. So there's a couple no's for switching. You're happy with you're happy with what you chose originally. Good. All right.
Josh put his confidence level back in there too. Thank you, Josh.
Yeah.
We appreciate it. Or Joshua.
Nice. So same thing applies. So I'm going to assign, if we want to take a gander at the code just quickly, this is down here is where the I'm changing my probability. So I could change my probability. I could probably make this.
So Steve, as you're changing that a little bit, we do have a clarification from Michael. How exactly does this differ from the forgetful problem? Because the forgetful problem was that we have win, lose, or not draw, but like game is ruined.
Yep.
So the main difference on this one is?
So and Michael, I felt the same way when I see a lot of these variations. The forgetful Monty Hall could be just like the lazy Monty Hall with a 50-50 chance of picking either of the 2 closed doors. In this one, we say he chooses the door that is he is closest to, and so I assign that a probability of he's going to pick this door with a 75% chance, and that way he would pick that one more often. But yeah, so I think they're both really close to each other because the same results are going to happen. But I'm not sure if we win more in this one or lose more in this one. I guess we're going to find out though here in a second because we're going to do 1,000 trials of 1,000 trials because we're 850. Mike said we'd go to 930, so it's all good. All right, so here we go. So in this one, I've got 1,000 trials of 1,000 trials, and it's going to be ones, zeros, and negative ones again. So I will build this and run this, and then let's see what comes up. Oh, and yes, I think what I need to do is I need to insert a data and statistics page. Oh, this is the best part.
Oh my gosh, this is my favorite part. Oh, so satisfying.
And it still looks, I don't know. I think we should try to change the probability, but I want to do, I don't want to do that. I want to do a box plot. I missed, oh, good. There's the box plot.
Wow, look at that median.
So let's go back up to this. And instead of I wish I would have done this better. Let's make that 0.95.
So we're changing that probability. This is the probability that Monty just opens the door right next to him, right?
So this is the leftmost door. He is he's like standing next to the leftmost door, and that's the one he's going to open. So regardless of the one I pick, the leftmost door that is closed is the one he will open, whether there's a car behind it or not. So, Bill, I wonder what will happen now. What do you guys think will happen now? Put that in the chat. This will be our last thing. So do you think it's almost a certainty that he picks that one leftmost door? Do you think switching is going to be beneficial or it's not going to matter? And the magic word is Monty. No change the results. Oh, nicely done. Nicely done, Joe. I like that. No change. I'm curious. Now I'm really curious about this. All right, ready? Let's run it. No, I don't know. I did not want a histogram. I like the dot plots.
I like the dot plots too.
I don't know. I don't know if it's a little bit. Let's run it one more time, just for kicks.
This is where when I tell my kid, when we're doing simulations with my students, they're like, I can't tell the difference. So I just have them screenshotting all of these and just putting them side by side by side by side. It's a great way to compare it, and students can convince themselves.
Box plot. So it seems like so far, this is like the third box plot we've had. I know it's just a small sample size, but the median value has always been just a little bit right of zero. Just a little bit right. I wonder if it is kind of normalish, except on the tails. That's pretty good.
That's pretty close.
All right. I tell you what, so we've got to leave time for Mike here at the end. I think we said we'd leave him 5 minutes. Anything for good of the order, anyone?
Michael says he was surprised at the number of outliers on that last one. I gotta admit, Michael, I kind of was too. I don't know why I was, but
I think that is.
I guess it's because I expected something normal, like approximately symmetric distribution. So seeing outliers kind of surprised me.
That's random. That's what random is. So
That's random. Yeah.
yeah, that caused a ruckus in math, folks. This is good, guys. On the stop sharing, Mike Houston. We will not go, and make sure you're unmuted, and we will not go to 9:30.
I am unmuted. Thanks, Steve, for the reminder. I'm going to have to bring you back next Tuesday to remind me of that.
Okay.
So I know that Steve and Rachel both are on Twitter, and so I don't know. I'm pretty excited about some of the stuff I saw tonight. I definitely did not know about those variations. So if you're excited about some stuff or you have questions about stuff, I know Twitter is a great way to get a hold of both of them. I believe Rachel is at Rachel H. Gorsuch, and Steve is, I believe, at Math Tech Coach.
Yep.
Math Tech Coach. So free to reach out to them on Twitter. As promised, we are going to be giving away to one lucky winner tonight a TI graphing calculator of their choice. See, I feel like this is kind of like, but there's no doors. This isn't a true Monty Hall problem. But I like to at least we're giving away something tonight. So tonight's lucky winner is Kelly Lee. So Kelly Lee, congratulations. We're excited to get you a TI graphing calculator. We'll be in touch over email in the next couple days to get a little more information from you, especially to figure out which graphing calculator you want. All right, to receive a certificate of attendance, go ahead and click the link in the chat window. And also listed is a link for the documents for tonight. And if either you're missing these or they're not working for some reason for you, just hang tight. You'll automatically get a follow-up email in a couple days. And that follow-up email will have lots of good stuff, like a link to the recording so you can watch this again at your own pace, a link to the certificate, a link to the documents, lots of good stuff. And if you're watching this on demand, go ahead and copy that link into your favorite browser to receive your certificate. So besides getting a hold of Steve or Rachel, if you have any specific probability or Monty Hall questions, if you have any questions for us, feel free to give us a call at 1-800-TI-CARES or send us an email, ti-cares@ti.com. We'd love to hear from you, especially if you have questions. When you leave the webinar tonight, a brief survey automatically appears in your browser, and your feedback really guides us as we plan future online events. This event that we did tonight is different than what we typically do on Tuesday nights, and I'm excited about it. And a lot of this has come from ideas that you all have shared, and Steve and Rachel have done some talking, and so this is really kind of a collaborative effort. But if you want to see more of this, let us know. If you think this is good and this is something that you can use with your students, feel free to let us know in that survey. If there's something that you've always been wondering about or want more information about, let us know that too. We hopefully can put something together to give you a hand. So huge thanks to Steve and Rachel for entertaining us tonight. It was fun. Thanks so much for the time you guys spent putting this together. And thanks a lot to everyone who joined us tonight. We hope to see you back online next week. Have a great night and stay safe.